Dear students, here's a short introduction to non-parametric and semi-parametric estimation. I'm going to divide this into 4 pieces. First talking about density estimation, then kernel regression, sieve estimation, and finally the partially linear model. The first 3 are going to be non-parametric, and the final one's going to be semi-parametric. So regarding density estimation, you know this very well from the histogram. This is actually an example of a fully non-parametric estimator where we're trying to estimate the probability density function of the underlying data. Intuitively, the histogram tells us what's the share of the data that falls into a particular interval. And mathematically, if B is the width of the bins in the histogram, then there's this equation for the histogram at a particular point x is we count the number of observations falling in the same bin as x, divide by the width of the bin containing x, and then the average of that. And that's exactly what this histogram is in math. The kernel density estimator has some of the same intuition in the sense that it's an average, and we're dividing by b, which we're going to call the bandwidth in kernel densities. It's kind of the equivalent of the width of the bins of this k function here, and the kernel. This k function is called the kernel, and it weighs observations differently depending on how far away they are from the point x, the red point, where we're evaluating it. So it sums over all of the I observations. One choice of kernel is just the Gaussian density, the PDF of the normal is one choice of k, but there's a whole width of a variety of choices that you can choose. But if you calculate your function like this, and similarly to here, this one puts weight 1 on observations in the same bin and 0 otherwise, but the kernel density puts continuous weight that's decreasing the further we move away from the point x. So this is what we get out for the same data that I showed you before. And this is, so the choice of bandwidth, you need to choose B, and it's choosing that you can either use just a plug-in rule like the Silverman's bandwidth, which is just a suggested rule based on some simple statistics about y, or you can use trial and error or use cross-validation. Here's if we use a higher bandwidth, 10 times the Silverman suggested bandwidth, and here's if we use a lower bandwidth. So you can see that they each make different types of. We don't like either of these two here. And this is much neater in a sense. So this one smooths out the data way too much. We're going to call that underfitting, and this one here overfits the data in the sense that it's way too jittery. We don't think that the true underlying process looks like that. But and it's this choice between overfitting and underfitting and balancing these two is what we in general in non-parametric estimation refer to as a bias variance trade-off. This one has bias because here we're too far up, and then we're too far down, and we're too far up. We're systematically deviating from the 2 PDF. And in this case, we have too much variance in our prediction. So our predicted PDF moves up and down too much. It's too jittery. So the choice of bandwidth must be made so that we balance the bias and variance, this trade-off between those two.